Units of measure. In order to prevent misunderstanding, it is important that we utilize the same units of measure across the board in all countries and in all languages. Currently, there are two main ways or two main systems in which we record or measure anything. The first is the English system, which is used in the United States, and the other is the metric system, which is used in the rest of the world. As scientists, we use what is called the International System of Units, or the SI system, which is based upon the metric system. The first unit we're going to take a look at is the meter. And the meter is a measurement of length. And a lot of you, if you are in the United States, would be familiar with the yardstick, which is used to measure. In comparison, using the metric system, we use the meter stick, which is slightly longer than a yardstick and is equivalent to 39.37 inches in comparison to 36 inches when you are using the English system. Here in this class, we will always measure length with meter or kilometers, which is 1,000 times a meter. The mass of an object is a measure of the quantity of matter within that object. Now, you may be familiar with weighing yourself on a scale, and you say, this is my weight. There is a difference between the mass and the weight. Weight of an object is a measure of the gravitational pull on its matter. And so your mass on Earth will be different from your weight on Earth will be different from your weight on the moon, whereas your mass will remain constant. The second. Now, a second is a measurement of time, or the measurement of the duration of an event. And the second is based on the measurement of time using the cesium atomic clock, and it's basically a measure of the transition on cesium 133. Now, one other unit of measure that you might not be familiar with is the Kelvin. The Kelvin is used to measure temperature. You may be familiar with measurements in Fahrenheit or in Celsius. In chemistry, we typically use Kelvin or we will use Celsius. The Kelvin scale is called the absolute scale, and it assigns 0 Kelvin to the coldest temperature possible. And we call that temperature absolute zero. Absolute zero is equivalent to negative 273 degrees Celsius or negative 459 degrees Fahrenheit. And at this temperature, molecular motion virtually stops. On the right, you will see a comparison of all three scales, the Kelvin, Celsius, and the Fahrenheit scale. At 0 degrees Celsius, water freezes. That is equivalent to 273 Kelvin, which is equal to 32 degrees Fahrenheit. To convert from Kelvin to Celsius or Celsius to Kelvin, you add 273 to the number that you have for degrees Celsius, and you will convert into Kelvin. To convert from Kelvin to Celsius, then you would subtract 273. Now, volume is a measure of the space within an object, and volume is any unit length raised to the third power. So you can measure length in meters and you raise it to the third power, it's meters cubed. Volume can also be expressed in cm cube or millimeters cube, mm cube. The other unit of measure that we use is density. Have you ever heard the joke, which would you rather carry, a ton of feathers versus a ton of bricks? Well, the truth is, both of them weigh the same, they are a ton. However, a ton of feathers may be less dense than a ton of bricks and gives the impression that a ton of bricks would be heavier. Density is the ratio of the mass of an object to its volume, and we calculate density by dividing mass by volume, and typically the unit of density is grams per cm cube. Those are the units of measure that we will be using. Hopefully you would have been familiar with most of them. For the new ones, then take a moment. I think Celsius and Kelvin and density will require a little bit of attention from you.